Good afternoon. Let's get started. So we are going to be doing lecture 2 today. And for your first quiz, which is next Thursday, yeah, the 23rd, it will be all of number 1 and just part of number 2. Okay. I'll tell you more about the quiz when more people show up. Okay. But here we go. Macromolecules. Before we do the biology regarding macromolecules, I have to teach you a little bit of chemistry first. Some of these chemistry concepts you might have learned already from your chem teacher, but some of it might be a little bit new. Regardless, I am just going to teach you all the chemistry you need in order to understand the biology of macromolecules. So what is matter? Matter is anything that takes up space. So it has volume associated with it, and it has mass. Right? So basically everything that we know is essentially matter. Okay? The table is matter. The air that we breathe is matter. And matter can exist in one of three states. Okay? It can be solid, it could be liquid, or it could be gas. They are not restricted to these states. They can change from one state to another by either absorbing heat or releasing heat. If you heat up solid enough, then they would turn into liquid. If you remove temperature from them, then they will freeze and become solid. So as long as you take away or give them sufficient amount of energy, they are able to change from one state to another. What makes up matter? Well, everything in the universe is made up of atoms. Atoms is the smallest unit of what we call elements that still retains the property of that element. So that sounds a little bit difficult to understand, but an element is the basic building block of everything that we know. So let's say we take carbon, for example. Okay, so carbon. Carbon is an element, and all the carbons in this whole world are made up of carbon atoms. So the carbon atoms are the smallest thing that still retains the property of carbon. And you can't go any further. If you divide the carbon atom further, then they will no longer behave like carbon. Okay, so it's the smallest unit of that element that still retains the physical and chemical property of that element. All the carbon atoms will behave like carbon, but they will behave differently compared to, say, oxygen atoms. Okay, so the smallest unit of an element is atom. What makes up an atom, though? Did you guys learn this yet in chem? What makes Yeah, so this is a review. I'm not going to spend too much time on it. There are three subatomic particles. Neutrons are neutral. Protons are positively charged, and they form the nucleus. Right? And then we have electrons, which are negative, and they kind of move around. Okay? So the number of protons do not change for an element. All the carbon atoms will have the same number of protons. If you change the number of protons, it becomes another element. Okay? So we cannot change the number of protons for the elements. You can, however, change the number of neutrons or the number of electrons. And we're going to look at that in a bit. That's you. The periodic table, which is right there, there's a big one on the side, lists all the elements that we have discovered so far. And these elements makes up everything that we know in the universe. Okay? For example, if you take hydrogen and you combine it with oxygen, you get water, right? H2O. If you can find it on the periodic table, then it is an element. Even though there are hundreds of elements on the periodic table, over 96% of our body is only made up of 5 elements, okay? Which includes carbon, nitrogen, oxygen, hydrogen, and phosphorus. You should memorize them, okay? So these 5 elements alone compose over 96% of our body. So where do we find? Oh, sorry.
I was gonna say, because in camp, we literally just learned this today, but she didn't mention phosphorus.
Well, we're gonna include phosphorus in biology. Yeah.
Oh, okay.
Yeah. As you see, phosphorus is important in DNA, for example.
Okay.
Yeah. So carbon, right? Carbon. Where do we find carbon? You want to tell me, or you want to tell me? Not so.
Say again your point. Like,
No, like carbon in nature. Like where would you find carbon? Was that? Yeah, okay, yeah, but like what about the element carbon? Pencil, yes, thank you. All right. So pencil right here, this stuff at the tip, people call it lead. That's really wrong, okay? We don't use lead for writing anymore. It's poisonous. This is graphite, and graphite is made up of carbon. Okay. Charcoal is made up of carbon. If you have a wedding ring, there's some carbon on it, probably too. Okay, what am I talking about? No, no carbon on it. What's a very precious gem that's made up of carbon? Diamond. That's right. Okay, diamond is just pure carbon, right? And so it's graphite, right? So one is worth less, pretty much graphite, and diamond is very expensive, right? And it has to do with how the carbon atoms are arranged. Okay, so that's where you will find carbon. Nitrogen. 70% of the air that we breathe are nitrogen. Okay, you breathe it in, you can't use it, so you just breathe it back out. 21% of the air that we breathe is oxygen, and obviously we need oxygen to survive, right? Hydrogen is also in our air, although not a lot. Hydrogen is explosive. If you have a chamber filled with hydrogen and you light a match, it will go boom. And phosphorus, you will find it in things like matches. Okay, it allows you to light them. Okay, so please remember the 5 key elements here that makes up your 96% of the body. Now, what about the remaining 4%? The remaining 4% is made up of what's called trace elements. Okay, trace elements. Trace elements are elements that you need in small quantity in the body. You don't want too much of it, but you need to have enough. Okay? Often, if you have deficiency, meaning not having enough, or if you have an overdose in these trace elements, it's going to cause some kind of health problems in the body. So trace elements include things like zinc, which is useful for your defense system. I'm sure you're familiar with calcium. You need it for stronger bones. But calcium are also important for muscle contraction. Every time you move a muscle, you need to have a little bit of calcium in order for that to happen. Iodine is something that is used by your thyroid gland to make hormones, to regulate your metabolism. Does anybody know where your thyroid is? Can you show me your thyroid? Right here, that's right. So that's the only place in the body that uses iodine. Okay, magnesium, it's also important for muscle contraction. If you go to Walmart or, basically most stores, you can buy supplements for these trace elements. But the general rule is don't take it because someone tells you it's good for you. You should only take these things if your doctor tells you, you are having a deficiency in them, okay? For example, you think calcium is good, but if you take too much calcium, they will start to crystallize in your kidneys and it could give you kidney stones. Okay? So you don't want to overdose. Too much of a good thing is not necessarily good.
Does iron also, is that included in the trace elements too?
Yeah, so this is not an exhaustive list, right? There are many other trace elements such as iron. We need iron for transporting oxygen. Right? A person with iron deficiency, they will have anemia, for example. Okay. Yeah. Yeah, so biotin, I wouldn't say is an element though. Remember, if it's an element, it has to be on the periodic table. Yeah, but biotin would be something like that. People take it for nails and hairs, right? It's what? No, kelp is not, but kelp is the source of iodine.
Oh,
yeah, that's right. Yeah, iodine, right? Some of you might remember this, earlier in the days. Iodines, they come in this bottle that's yellow, and then you put it on your wound, right? To disinfect. Anybody know what? Yeah? Yeah, brownish color. You're not gonna drop that into your mouth and eat it, right? Like it's poisonous. So you have to take it from some natural source, like kelp. All right. So, like I said, having too much or too little of these trace elements will often cause problems. This is what's called goiter. That's when your thyroid gland enlarges because of iodine deficiency. Okay, it's not the only cause of goiter, but this is one of the reasons. Yes.
So why, when I get sick, let's say I feel like your glands like they.
Oh, those are not the thyroid. Those are your lymph nodes.
Oh,
Yeah,
okay.
right. Okay, so this is not something we have to worry about too much in North America because where do you get your iodine, guys? That's right. Okay, the salt that you buy from supermarket, they are iodinized. They have iodine added to it to prevent these kind of situations. Okay. Naturally, though, you can get iodine from most seafood. Right, they are quite rich in iodine. Calcium deficiency can lead to osteoporosis. Okay? Osteoporosis is the weakening of your bone because you don't have enough dietary calcium. You're not taking in enough calcium, and your body starts to absorb it from your bone. And osteoporosis is a concern for the elderly. If they fall, they can break their hips, for example, and it's the main one of the main causes of debilitating falls. Okay, next we're going to talk about isotopes. So remember, I told you protons do not change, right? But neutrons can change. For example, we can have carbon 12. Okay, don't worry about how to count these neutrons and protons. Your chem teacher will teach you. But I'm just going to write it down to help you understand it. Carbon 12, for example, has 6 protons and 6 neutrons. And carbon 13, since it's still carbon, it has 6 protons as well, but it has an extra neutron. And then you can also have carbon 14, which would have even more neutrons. Okay? So by having different number of neutrons, the atoms might be heavier or lighter. Okay? Some of these isotopes are unstable. And that means they could break down on its own. And when isotopes break down, sometimes they give off radiation. So we call them radioactive isotopes. Radioactive isotopes. And radioactive isotopes are useful in various applications. For example, carbon-14 is used in carbon dating. When they dig up like a fossil or something and they want to figure out how old it is, they check the amount of carbon-14 that's left, and they could do math to figure out how old the skeleton is. Okay. Iodine-131 is another radioactive isotope. It is used to treat thyroid cancer. And remember, thyroid is the only place in the body that uses iodine. And so if you inject iodine into the person, it will automatically go to the thyroid. And when it breaks down and gives off radiation, the radiation is going to kill the cancer cell in the thyroid. Yeah.
So I have hyperthyroid. One of the things you have to do is like the radioactive iodine. Is iodine itself radioactive?
No. So
like there's something.
So iodine, if you look at the iodine on the periodic table, you will find that so like each atom has different versions of it. Okay, so only some versions of it is going to be radioactive. So for example, carbon 12 and 13, they're not radioactive, but the 14 version is. Iodine 130 is not radioactive, but 131 is radioactive. Okay, so it's radioactive because it's like too big, it's too heavy, it's unstable. Okay. If you have a smoke detector at home, and you should, by law, you need to have one, keeps you safe. There's a little bit of radioactive isotopes in it. It's called americium-241. That's how the smoke detector works, and that's why smoke detectors has expiry dates. Okay, once the isotope all breaks down, it will no longer work, and you need to buy it. But don't worry, you don't have to throw them away because you're concerned about the radioactivity. The radioactivity is very, very small. It's not gonna, hurt you in any way. Okay, you receive more radiation from your phone than you would from your smoke detector. Okay, so that's isotopes. Okay. Yeah, you guys are not with me. A lot of you are just like staring into emptiness. Okay. It kind of okay. Wait, I know it's been a long day. 3 hours of chemistry is draining, but yeah, yeah, you have to wake up for this stuff. Okay. All right. In case you missed it, do protons change? No. Okay, protons of all the elements are the same, of the same element are the same. If you change the number of neutrons, what do you get? Isotopes. That's right, isotopes, right? If you change the number of electrons, then you get ions. Okay. So it's possible for atoms to gain electrons, for example. Gain electron. Okay, it could be more than one. When that happens, it becomes more negative, and we get a negative ion.
Can you repeat the electron part again?
Sure.
So different, if it's different, if the electron changes, it's an ion.
That's right. Yeah. And when we talk about electrons, you can either gain them or you can lose them. Okay. So if an atom gain electrons, it becomes more negative, and we call it a negative ion. Okay, negative ion. On the other hand, it's possible for them to lose electron or more than one. And when you lose electron, they become positive ion. Okay. Now you have a water bottle there, Emmanuel. Do you see any thing on the label at the back? Any elements on it? Nothing? Oh, maybe it's not a good brand. Saying. So, for example, a lot of times you would see things like Na, okay? Na plus, right? Cl minus, K plus, Ca2 plus. These are all ions, okay? That's sodium after losing an electron. That's chlorine after gaining an electron, right? And these things actually are very important in our body because they form electrolytes. Okay, electrolytes. And when a person is dehydrated, right, they lose a lot of electrolytes, and that could be dangerous. Okay. One of the leading cause of death in low-income countries are kids having diarrhea because they don't have access to clean water. When they have diarrhea, they lose so much electrolytes, they're not able to replenish them. Okay, and then they die from that. So where can we get electrolytes? Well, if you drink Gatorade, it's mostly sugar, but then there are some good electrolytes in there as well. Okay. It's also true if you do strenuous exercise, it's not a good idea to just drink water alone to replenish. Okay, because when you sweat out the electrolytes, and if you only drink water, you will dilute your electrolytes further. Right? So it's recommended that you drink your water, sure, but like have a banana or something to replenish the potassium and so on and so forth. Okay. Different number of neutrons, isotopes. Different number of electrons, ions. All right. Hopefully you have a good understanding of what atoms are now. Okay. Atoms are individual building blocks, if you would, and they mix up the elements on the periodic table. So what can you do with these atoms? Well, I told you already, if you take hydrogen and oxygen, you can put them together and form water. Right? What's the formula for water again? H2O, that's right. Now, this ratio between H and O is a fixed proportion. All the water in the whole world is H2O. Doesn't matter where you get it. It's always 2-part hydrogen and 1-part oxygen. If you change the ratio, you will get something different. Let's say you have H2O2. Does anybody know what this is? Hydrogen peroxide, that's right. Okay, this is it comes in a brown bottle and you use it as a disinfectant, right? Okay, you can drink H2O, no problem, but it's poisonous to drink H2O2. Just by having an extra oxygen completely changes the property of the compound. Okay, so here is another example. Sodium. Okay, sodium is Na. It is a metal, and it's a little bit different than what we visualize metal to be. When we say metal, you think of something that's strong, hard, shiny, right? Conducts electricity, but not necessarily, okay? Sodium, it's a metal and it's quite soft. You can actually cut it with a kitchen knife, and it reacts violently with water, okay? That's why the person is wearing a glove. Just the moisture on your hand can set off a violent reaction. If you have a chunk of sodium this size, and you drop it into a bucket of water, it will literally blow up. Okay, you can search that on YouTube and watch people do it because people do all sorts of stuff online, and it's too dangerous to do in class. So sodium is not something you want to keep at home. It's dangerous. Chlorine is an other element. Okay, so if you look at the chlorine, they're made up of little chlorine atoms. And chlorine is poisonous, okay? They use chlorine gas to make the mustard gas during World War II. And when people breathe it in, it destroyed their lung surface lining, and they suffocate and die, right? So again, not something you would want to keep around you because it's so dangerous, okay? Yeah, keep that in mind. I'm going to go back to that point, okay? Now, sodium is explosive. I told you chlorine is poisonous, but if you put them together, they form sodium chloride. Okay, and sodium chloride is not an element, right? Because you can't find sodium chloride on the periodic table. You can find sodium, you can find chlorine, but not when they're together, right? When you put them together, you get a compound. Okay, compound. Right? Elements can combine together to form compound. If you look at the individual elements, they are made up of individual atoms. But if you look at the compound, you get individual molecules. Okay, so water is a molecule because it's a combination of hydrogen and oxygen. Right? So when you put sodium and chlorine together, you get table salt, sodium chloride. Okay? And this is neither explosive or poisonous. You put it on your fries and it's fine, right? So the point I'm trying to make here is this. When you combine elements together to make compound, the properties of the compound are very different from the components that are used to make them. Okay? Even though these things react violently on their own, not so much when you put them together. Okay? Any questions? Now, I need to clarify something for people, okay? Because it might not occur to you now, but then after when you go home and you study the note, and then you might think about this, and then you will start wondering like what's going on, right? So you were mentioning, people sometimes say it like this. Oh, the pool has a lot of chlorine. Have you heard people say that? Right? Yeah. Now, when they say the pool has a lot of chlorine, they're not necessarily thinking about chemistry class, okay? So when they say chlorine, they don't mean chlorine gas. Right? It's not like these green poisonous gas bubbling from the pool and we're gonna go take a dip, right? When they say the pool has chlorine, what they really mean is the pool has chlorine containing compound, okay? Such as bleach, okay? Bleach has chlorine atoms in it, but it's not like pure chlorine. You understand that? Right? People take calcium supplement. It does not mean you're taking elemental calcium, which is, by the way, also explosive like sodium, okay? You're taking a calcium containing compound, Okay? When you say there are a lot of sodium in the food, you're not saying sodium element. You're saying probably sodium chloride. Okay? So it's just that people are using it like not strictly correctly, right? But I want you to understand and make that distinction. We together? All right. So how do you put the atoms together? Well, there is a little bit of a chemical glue that we can use to stick them together. And there are two main ones here, and you're gonna spend weeks talking about this in chemistry. I'm just gonna give you like a brief overview here. Okay? So the first one is called ionic bond. Okay? Ionic bond involves the transfer of electron. Okay, or it can be more than one. Okay? For reasons I'm not gonna go into, metals like sodium, they like to give off electrons. They want to give them away. Whereas non-metals like chlorine, they want to pick up electrons. So that's perfect. If these two things come together, then they could form a bond. Right? This one does not want electron. This one wants it. So let's make a bond. Let's form a bond and then form a compound. Okay, so that's ionic bond. Ionic bond tends to be stronger. Okay, it's very hard to separate them. They have very high melting point, for example. Okay, in order to melt salt, you need to crank up the temperature to thousands of degrees. Okay, the other one is called covalent bond. Okay, so covalent bond, instead of transfer of electron, it is a sharing of electron. Okay. So in the case of water, the hydrogen is going to be providing one electron, oxygen is going to be providing another one, and then they will share. Okay. So instead of transfer of electrons, you have sharing of electrons. All the macromolecules that we will be learning in the lecture, all of them will be covalent. Okay. All of them will involve sharing of electrons as opposed to transfer of electrons. Now, there are many different molecules you can create by combining the atoms together. And if the molecule contains carbon, then we say it is an organic molecule. Okay. The definition here has nothing to do with the food definition. Okay, so some people get confused between like organic molecule and organic food, totally different things. Okay, so in chemistry and in biology, if something is organic, it just means it has carbon atoms in it. So for example, there are several important biologically important molecules that are organic, like glucose. Okay, glucose is C6H12O6. You might not remember it now, but you will later on. Okay, we're going to be talking about glucose quite a bit in the course. And it has carbon, 6 of them, in fact. That's what makes it organic. Okay. Proteins are also organic because it has carbon in it. However, not everything that is organic or necessarily associated with living things. There are many things that we use in everyday lives that are made up of organic molecules. Okay? So polyester, right? That's organic molecule. We don't have it in our body. Polyester is used to make like jackets, for example, right? Like a water-resistant surface for your windbreakers, for your winter jacket. Methane is another organic molecule, is CH4, and it's a greenhouse gas, and it's not really in the body. There are some exceptions though. CO is carbon monoxide. CO2 is carbon dioxide. You don't have to write that. I'm not going to test you on that. And you will learn them later anyways, if you can. And CN, anybody know what CN is? Poisonous, in spy movie, they hide it in their teeth and then they would bite down into it if they get caught. That's right, cyanide, okay? CN is cyanide, okay? Hydrogen cyanide, it's poisonous. We will learn why it is poisonous in lecture 5. Okay, so these are exceptions. Even though they have carbon in it, they are not organic, okay? This is cyanide if you want to look it up later, okay? But we will learn about it. Almost there. Yeah.
So would the organic molecules be formed in the living thing?
It could, it might, but it doesn't have to be, right? So like these are organic and it's in a living thing. These are also organic, but not in living thing. Okay? So plastic is actually an organic a molecule. If you cook with those non-stick pans, the black coating, the Teflon, that's organic. It's carbon with fluorine, but that's not in a biological system. Okay, I want to take a moment and draw some water molecules with you. All right, so this is water molecule. To draw a water molecule, it's like drawing Mickey Mouse. You have the face, and then you have the ears. Okay? The face is the oxygen, and then the ears, they are the hydrogen. This is a water molecule. And the bond that's holding the atoms together, this bond right here, that is a covalent bond. And if you remember, covalent bond involves sharing of electrons. Okay. Now, the word sharing is it's interesting. When you say you share something, you would expect like 50-50, right? Okay. But that's not the case for my kids. If I buy them a toy and I say, share, usually one of them would hog it, okay? And they get to play with it more than the others. And that's kind of the situation with oxygen and hydrogen. Even though they are sharing the electron, it's not half-half, okay? The oxygen is like my older kid. She hogs the toy, right? So the oxygen will pull the electron towards itself and use it more often than the hydrogen. As a result of this, the oxygen is going to be slightly negative. And then the hydrogen here will be slightly positive. Okay. Due to uneven sharing of electrons, part of the water molecule is slightly positive, and part of it is slightly negative. This makes the molecule polar. Overall, the molecule is still neutral. There isn't excess or missing electrons. They are all there, but it's how you distribute the electrons in a molecule, okay? Because of the property of oxygen, they pull the electrons towards itself. This part is slightly negative, and then these parts are slightly positive. That makes the molecule polar. Now let's try to put two water molecules next to each other and see what happens. Remember, the oxygen is slightly negative, and then the hydrogens are slightly positive. Opposite charges attract each other, right? Like a magnet. So when you put them close to each other, the positive hydrogen will be attracted to the negative oxygen. Okay. So there's going to be an attraction between them, like that. If you want, you can draw one more. So again, the negative here is going to be attracted to the positive, and then the positive is going to be attracted to the negative. So these attractions, they are called hydrogen bond. Now, I don't want to overwhelm you. I'm sure you're already a little bit overwhelmed, but like for hydrogen bonds, it's something we will talk about again and again as we move through the course. And it's nothing complicated. Just think of it as like magnets attraction, if you would. Okay, so anytime I mention hydrogen bonds, it's just talking about like two pieces of magnets attracted to each other. Okay, so the more hydrogen bonds there are, the more attraction there will be. Okay, and then the tighter two things are going to be. Okay. Any questions? So what? That they have attraction. What's the big deal? Well, this attraction between the water molecules actually gives water a lot of its unique property. For example, if you consider all the water molecules on the picture, everything is kind of clinging onto each other, and that creates surface tension. Okay? You know those bugs that can walk on water? Right? Yeah. The reason they could do that is because of the surface tension. It allows the water to form like a resistant film, if you would, and things don't break through easily. Okay? Imagine this: if you have a dime, and we don't have pennies anymore. Dime is the smallest one. If you imagine a dime, and then you have like a water dropper, eyedropper, and then you're gonna put water on it. Okay, you're gonna drop water onto the coin. How many drops do you think you can fit? 5. Okay, anyone else? How many drops do you think you can fit? Throw me some numbers. 1. Okay, yeah. 1, 5. Anyone else? 3, 2. Still conservative. Okay. Would you be surprised if I say if you do it slowly, you can fit 10 to 15 drops? Yeah, you could. Okay. Yeah. And that is because of surface tension. Okay, that is because of surface tension. So let's just, in our mind, visualize this. Right? Let's say I take a table here, and then I ask, 10 of you to stand on the table without falling over. In order to achieve that, you probably have to hang on to someone to prevent them from falling over, right? Yeah. Okay, and that's exactly what's going to happen when you put water onto the coin. It's going to form a dome shape, the water, okay? And the water molecules at the edge are being held in by other water molecules because of the hydrogen bond. Right? It's like the water molecule here is not gonna spill over because there is another water molecule clinging onto it, right, with the hydrogen bond. You understand? And that's also the reason why you can drain water through a straw. Right? When you suck up the water molecule, it pulls the next one up and the next one up and then up it goes. Okay? So this is one of the properties of water that can be explained by the hydrogen bonds. Okay, but again, the key thing to remember is anytime from now on, if I say hydrogen bond, it just means they are attracted to each other, okay? That they could, form a little interaction with each other. Now, we cannot live without water for very long, okay? What was the saying? Like you can live without oxygen for 3 minutes. Without water is 3 days, right? Okay, and then without food, they say is 3 weeks. And that's because water is essential for life. And one of the reasons for that is because water is a very good solvent. Okay, solvent is usually a liquid that will be dissolving other things. So if you think of these fruit punch packets, right, this would be called the solute, and then you can mix it with the solvent, and you get a solution. Okay, you put the solid into the liquid, it dissolves, and you get a solution. So all those electrolytes that we were talking about, they are dissolved in the water that's in our blood, right? And like I said, they are important for normal bodily functions. Okay, so give me an example of something that you can dissolve in water. Salt, that's right. Sugar, yeah. So salt and sugar are what we call hydrophilic molecules. Hydro is water. Hydro is water. Philic is loving. Okay? So these are water-loving molecules. Okay? Since water is polar, it is able to dissolve other polar substances. Okay? So sugar is polar. Salt is ionic. Ionic is similar to polar, and you can also dissolve them. Okay? And anything that can be dissolved in water is hydrophilic. So when you put sodium chloride, when you put salt into water, the chlorine is negative, and it's going to be surrounded by the hydrogens of the water. Whereas the sodium is positive, and it's going to be surrounded by the oxygen in the water. Okay. Now give me something that cannot dissolve in water. Oil, that's right, oil. So oil, they are nonpolar and they don't dissolve in water. We call them hydrophobic molecules. Hydrophobic. Anything else besides oil? Vinegar can dissolve. Yeah, vinegar is hydrophilic. What's that? Sure, hold on. Let me put vinegar here. Vinegar. Honey. Hydrophobic. Did someone say sand? Yeah, I mean, I agree, but then it's not really the right context, right? Like for example, if I put this in the water, the brush in the water is not gonna dissolve. But I'm not gonna say the brush is hydrophobic, right? Like it's not really the right descriptor, even though it's true that it doesn't dissolve. Anything else from your kitchen that does not dissolve in water? Paper, did you say? Oh, peanut butter, yeah. So peanut butter is oil based, right? So it's not gonna dissolve. Wax is another one, right? If you have hot wax, it drops on the water, immediately it floats to the top, right? Okay, so these are hydrophobic. Okay, oil, butter, peanut butter, what did I say? Wax. Right. So if I give you a list of things that are hydrophilic and hydrophobic, you will know which one is which? I hope so. Okay, we're almost done the chemistry part. We can determine the acidity of a solution by measuring its pH. Okay, pH. If it's neutral, then it's 7. And the scale goes from 0 to 14. If it's a 7, then it's neutral. Okay, pure water is neutral. Okay, tap water is not pure. If I get some tap water and then I measure it, the pH is a little bit acidic. In most cases, depending on which part of the city you're from. Okay, but pure water is 7. Okay? Things that are lower than 7. Okay, things that are lower than 7, they are acidic. Okay, this is pH less than 7. Okay. So yeah, tomato is acidic. Lemon juice, lime juice, orange juice, they are all acidic. Okay, they are sour usually. Vinegar is acidic. Okay. Do you know you have acid in your stomach?
Yeah.
It's hydrochloric acid, really strong. It has a pH of 1. It's strong enough to dissolve a nail. Not that you should be swallowing them. Anything higher than 7 is, anybody know the opposite of acidic? Neutral is 7. Base, that's right. This is basic. Basic. So think of cleaning products. Okay, like baking soda is basic. Ammonia is basic. Bleach is basic. They tend to be bitter in taste. They tend to be slippery to the touch. Okay, sometimes like think of soap, right? Okay, slippery. And yeah, they are greater than 7. All right. So if you have a hot burn, right, and you have too much acid, then what do you take? Ever see that commercial with the chicken fighting back? Huh? We have hot burn. What do you take? Tums, yeah. Tums, right? Yeah. Pepto-Bismol, right? That's Tums, yeah, basically. And Tums is basically a basic substance, okay? It's calcium bicarbonate. It will neutralize the acid and put it back to like, a more comfortable pH. Okay? Blood is, of course, essential for life. And the pH for blood is very narrow, about 7.35 to 7.45. You don't have to memorize these numbers, okay? Anything lower than 7.35 is acidosis. It means you have too much acid in the blood, okay? You can fall into a coma and it's life-threatening. Too high is no good either. Alkalosis, okay? 7.45, higher than that is good. It's not good either, okay? But don't worry, we don't go into a coma every time we enjoy a glass of orange juice because your body has various mechanisms, various ways to help maintain that homeostasis. Remember we learned about that word, right? To maintain the balance within this narrow range. It's only when those mechanisms are not enough, then you fall through the lower range or you go above the higher range, and then we're gonna have a problem. Okay, next semester we will learn about how the respiratory system and your kidneys help you maintain the blood pH. Okay, and that is it for the chemistry, I think. All right, let's try concept check question here. See how much you've learned. Yeah, you already know the answer. Very good. Anyone else? Yeah, good. There. Those of you who are new to the class, you just show me the finger. If you think it's A, put up 1. If you think it's B, very good. Anyone else? Good. Yeah. Now you gotta look at me after you put up a finger so I can tell you. Try again, please. Anyone else? Good try. Not quite. Try again, please. Oh boy, am I not doing a good job? Try again, please. That's good. Yes. Sometimes hard to tell from an angle. All right. Water molecule is polar because, well, we literally wrote it down. So if you did not write this down, write it down next time, okay? Due to uneven sharing of electron, parts of the water molecule is slightly positive and part of it is slightly negative. This makes the molecule polar, okay? So the answer is C. Okay, uneven distribution of electron. They're not being shared equally, and so the oxygen is slightly negative. Are we okay?
Yeah.
All right, I think we have most people in the class. I just want to tell you, first of all, I can tell who has logged on to the page and who hasn't, and I think over 10 of you have not done that yet. I'm not going to say who it is, okay? But you should. You need to log on to the page for your own good, okay? Because number one, you will be able to find the lecture recordings for classes that you might have missed. There are notes that we took in class, like the one we just wrote on the board. But more importantly, if you go into the lecture folder, study resources, there is the self-quiz, okay? Only 3 people has done the self-quiz, okay? Weekend is coming up, okay? And it's going to be cold. Why not stay home and do more self-quiz, okay? So that's self-quiz number 1. You can do them as many times as you want, okay? And when you submit, it will tell you what the right answers are. You need to try them to prepare for the quiz, which is next Thursday, okay? Next Thursday, okay? You will also have self-quiz for lecture 2, okay? So do them. You won't be able to do all of them, but doesn't matter. It doesn't count, right? So just do the questions that you know, okay? And the most important thing, if you go to quiz number 1, okay, you will see the answers to the concept track questions, the one we do in class with the 1, 2, 3, 4, right? If you miss some of them, the answers are there. And wait, is this the wrong class? This is the wrong class, sorry. That was my online class. This is you. Okay, same thing. Right? So in quiz 1 information and review, I have to make it visible to you. There you go. That's the quiz 1 information. Okay, click onto it. I gotta type in the date. I forgot. You know what? Let me type it in right now. What was it again? You keep on reminding me. Thank you. It is going to be Thursday. Okay, January 23rd. Okay. And it will cover all of lecture 1 and part of lecture 2, up to and including lipids. I don't think we can finish lipids today, but it's very short. Whatever we don't finish, we'll finish on next Tuesday. There will be 15 multiple choice questions, 5 short answer questions. Some will be from the study guide. So if you haven't done the study guide, do them. Yeah.
Like when it comes to like passengers or like ready things, we have to draw like an example. Like no, we do like the beaker. I mean like the.
You only need to draw if I ask you to draw. Okay. If it's a written response question, you have to answer with words. Okay. But you can support your answer with a diagram if you want. Okay. But a diagram alone is not going to get you full mark. Okay. Quiz will be 40 minutes. Okay. Please be on time. I literally will start at 12:30. Okay. There will be a seating plan as well. Okay. I will put your names on the board and then you will find out where you sit. Okay. You don't get to sit with your friends. I caught quite a bit of cheating last semester. Please don't cheat. Okay. It's disrespectful and you don't need to cheat. I will tell you exactly what's on the quiz. Okay. I'm going to tell you right now. Okay. You just need to study and do it. If you cheat and I catch you cheating, we, as in like everybody teaching the program, we have a list of people who have cheated. Okay. So you cheat here and then you get caught, everybody will know. So next time, if you cheat again in chemistry and you tell your chemistry, oh, it's my first time, I didn't know. Well, guess what? She knows, okay? Because we have a list. We have a naughty list. And trust me, you don't want to be on it, okay? All jokes aside though, okay? No cheating, please, okay? 40 minutes, plenty of time. No need to worry as long as you arrive on time. You need a pencil, okay? You need a pencil for the quiz. Do you guys know how to use these things?
Yeah.
Yeah. Okay. If you don't know, come talk to me during the break. I'll let you know. They only work with pencil. Okay. Pencils. There's nothing that ticks me off more than people filling these things with a pen and then they get 0 and I have to refill it for them with a pencil. Okay. Don't do that. Bring a pencil. Okay. Also, more reason not to cheat. The person next to you is going to have a different quiz than you, okay? I have multiple versions, so if you copy them, likely you're going to be copying the wrong answer, and you're going to be on the naughty list. If you need accommodations, okay, if you have an IEP from high school or if you have some kind of learning disability that require accommodations, you need to send me an email and let me know. I will redirect you to the Center for Accessibility Learning so they could, get you the right documentation to give you extra time. Okay, how do you prepare for the quiz? There is this review video. You have to watch it, okay? Everything you need to know on the quiz is going to be in this review video. All right? That's me. Yeah. It's my class. Okay. Yeah. So like it's gonna be on the quiz. Right. So watch it. And don't wait until last minute. Okay. It's really funny. Because on YouTube you can track the number of clicks, right? Okay. It's usually nothing, nothing, nothing. And then right before the night of the quiz goes skyrocket. Too late. Okay. Start early, start watching them, and then take notes. Okay. Everything that's mentioned in the video will show up on the quiz. Okay. Let's start at 0. Okay. Yeah, that's right. And then you might have to watch some commercials. Okay. But yeah. Anyway, like I said, I don't get money when you watch the YouTube video. It's only for your own good. Okay. Yeah, they will fire me if I do have a side job or something. I don't know. I don't know. I'm kidding. But anyways, you guys understand what to do? Yeah. Okay. All right. First quiz is easy. Okay. I'll get you later. But for the first quiz, it's like freebies. Okay. Um. Yeah. Let's take a quick break and then we'll do more after.
What time? Oh, an hour.
All right, now that we get the chemistry out of the way, we're gonna move on to the biology aspect of the macromolecules. Here is a list of macromolecules we will be looking at. We have carbohydrates, people call it carbs, proteins, lipids, and nucleic acid. Okay, each of these macromolecules play an important role in keeping us alive. And what we're going to learn about them is their chemical structure, their biological functions, as well as where can you obtain them through diet. Okay, so like I said, the quiz next week will only cover up to carbohydrates and lipids. Okay, proteins and nucleic acids will not be on. Okay, only carbohydrates, lipids, and all the chemistry background stuff that we talked about. Okay, let's take a short note here to help you understand the fundamental principle behind this thing. All right, so this is monomer and polymer. Oh.
That monomer is what they use like when they do my nails.
Oh, yeah. I did not know that. Learn something new every day. Yeah. Uh-huh. And then they put like the UV light to cure it. Yeah. So this is probably related to this. Yeah, maybe. Okay. So monomer are basically individual building blocks. Okay, they are not linked together. They're not connected together. Okay. So think of like, making a bead necklace or something, right? The individual beads. These are monomers. Okay. They are building blocks. And you can connect them together to build a long chain. Okay. To build a long chain. Okay. Now, there are different ways to link them together, right? like using UV light is one example. But in the body, if you want to link them together, you need to remove water molecules. Now, there is a name associated with this process. When you are removing water molecule, you are basically dehydrating them. So this is called dehydration synthesis. Now, I'm really sorry, but there are often multiple names for the same thing. And I'm showing you just in case you read about it, okay? Condensation reaction. Just remember one and use it on the test if you need to. You don't have to mention both. These processes, it's the same thing, okay? Same meaning. Is how you would connect the monomers together to form a long chain. Okay, this long chain is called a polymer. Polymer. Of the four macromolecules that I showed you, three of them are polymers. Okay, and polymers are commonly used in other organic molecules. Right? We already talked about polyester. That's a long chain of esters connected together. Okay, you learn what esters are in chem class. Your plastics, they are polyethylene. Okay, it's a bunch of things connected together. Okay, so monomers can be connected through dehydration synthesis, where you will be removing the water molecule, and then you would form a long chain.
Right, what is the
What is the ester? Oh, ester is just like a carbon connected to oxygen and then to another oxygen. It's just like it's like a chemical group. Yeah. Polyester would be like, like her jacket, the material, that's polyester. Okay. Okay. When we eat our food, you eat your starch, from pasta, bread, rice, they will enter our body as polymers, and you would have to break them back down into monomers so that you can absorb them as nutrients. If you want to connect them together, you are going to remove water molecule. So if you want to break them, what do you think you have to do? Yeah. Add H2O molecules. And this is called hydrolysis. Hydro means water. You should know that by now. And lysis is to break. Okay. This is water. Okay. So hydrolysis is to break apart the polymer by adding water. Another way to understand it is to think of a train. Okay, train is really long and it's made up of individual carts, right?
Yeah.
Okay. Most of the time, the carts are the same, but if you ever stop for one of those long CN rails, then the carts might be different, right? Depending on what cargo they have. And that's how it is with the macromolecules. Some of them have the same monomers, others not so much. And we'll learn all about them. Okay. So here it is. These are the different macromolecules. These are the name of their polymers, and then these are the name of the monomers. Don't worry about memorizing it now. We will look into them more closely later on. Okay, what does it mean by removing water molecule? So here I have a monomer. Okay, don't worry about what the hexagon means at the moment. I will explain later. And this is another monomer. So you can see on each of the monomer, there is this OH group on them. And if I want to chemically connect them together, I would have to remove a water molecule. So you will have to remove the OH from one of them, and you remove the H from the other, and that's how you get the H2O. And then you will connect them together with a bond. This is a covalent bond. It's sharing of electron. So now they are linked together. Okay, this O is this O. Okay, you're taking just H2O, right? Two H's and one O, and the remaining O will allow you to connect them together. Okay. Let's practice. Actually, you know what? Let's go through a few more slides first. The opposite is true. If I have two things that are already linked together and you want to break them apart, what's the name of the process? Hydrolysis. That's right. Hydrolysis. And that involves the addition of water to the bond. So here's a water molecule. We would add the OH to one side and we would add the H to the other side, and then you would break them apart. Okay? So when we eat food, they usually come in as molecules that are connected, and you have to break them apart before you can absorb them. Okay. I know the hexagon can be confusing at the moment, but just stay with me. It will all make sense in a bit. Okay, let's see if you understand this stuff. Is that an answer? No, okay. Yeah, that's good. Anyone else? Try again, please. What is that? Wait, did I do it wrong? No, that's good. Good. Try again. And no, no, good.
Oh.
Good. That's good. Yes. Anyone else? Okay, so I'm getting a lot of mixed answer here. Okay, let's see. We have a hexagon here, right? With the OH and a pentagon with OH. If I need to, yeah, yeah, that's okay. I know. Some people see both hexagon, right? Hexagon and pentagon. If you need to connect them together, you need to remove H2O, right? It doesn't matter where you take the OH. You take this one, take this one, and then this is the answer, right? You see that? Yeah, hexagon and pentagon, right? Where?
That's why.
The size?
Yeah, like, okay, sorry. I forgot.
Oh,
I just want to.
okay. Yes, Zora?
No, I just wanted to answer the question, please.
Oh, yeah. Okay, well, let's do one together. I mean, not together, like you do it and I'll take it. Go and take it out. Okay, can you draw it, please? Draw the answer. If I want to connect these things together, this is a square, okay? So, if you want to connect these two things together with dehydration synthesis, what is the answer? Okay, you can show me. I'll come over. Oh, yeah, there you go. Very good. Did you have water as well? Yeah. Wonderful.
1, 2. Oh,
You have it? All the way. No, no, no. Yeah, that's it. That's lots of water. Got it? Yeah, just make sure the line is stay at the corner from the corner. Yeah. Yeah, looks good. Yeah, good. Plus water. Plus water. Plus H2O. You got it? Yeah, just make it a little bit bigger and it should be okay. Pretty good. Yeah, that's it. Like plus water, right? Plus water. Just on the side, plus H2O. Just remember you have to take the water out, right?
Oh, it's. So that, then does it matter where it's.
Just on the side. Make sure this line goes to the- not like in the middle. You see how this is important? Because that's what we do. To connect them together, I have to remove the water volume.
But if I look at that, why am I doing the same?
So if you remove the water, then it's gonna be part of the.
Well, I'm just putting it at the side.
Yeah.
I'm only after getting rid of it.
That's right. So that's what you're gonna get to the end, so you get that.
Oh. Okay, wait.
H2O. Yes, yes. That's right. Okay, most of you got it right. Square, right? O. And then the pentagon, right? Okay, make sure it goes to the one of the corners. Okay, not like in the middle of the line. You understand?
Yeah.
Right? And then plus H2O. Because look, you're taking the OH from one and the H out, right? And this basically forms H2O, right? So you have to put that in as well. You understand? Okay, if I ask you to draw this on the quiz, you will know how to do it.
Yep.
Okay, carbohydrates. Carbohydrates are organic molecules. All the macromolecules are organic because they all have carbon atoms in them. Okay. And in addition to carbon, it also has hydrogen and oxygen. Remember the 5 elements that makes up over 96% of us? Carbon, hydrogen, oxygen, nitrogen, and phosphorus, right? So the macromolecules we are looking at will only be made up of these things, right? For carbohydrates, it's CH and O, okay? Why are carbohydrates called carbohydrates? That's because the ratio between carbon and H2O is always 1 to 1. For example, if N equals to 6, then it will be C6H12O6. Okay? The ratio is always 1 carbon and 1 water. That's why it's called carbohydrate. And again, this is glucose. Right? Don't worry about memorizing that for now. You will eventually. What do we need carbohydrates for? Carbohydrates, depending on the organism we're talking about, they are useful for various reasons. For animals, including humans, we use them for quick, short-term cellular energy. Okay, you can burn the glucose in the cell, and that creates energy that will power your bodily function. In plants, they use carbohydrates for structural components. The fibers that are in the plant, if you think of celery sticks, they're crunchy, right? That crunchiness, that structural integrity is a form of carbohydrate. Shells are also made of a specialized kind of carbohydrates, as you will see. Okay? We humans, we don't use carbohydrates for structure. We just use them for energy. Where do you, oops, before that, this is the equation called cellular respiration. You don't have to memorize it yet. Okay, we're going to spend a whole lecture learning about this equation later on. Okay, so for now, I'm just showing you. This is called cellular respiration, and you basically take the glucose from the food, react it with the oxygen that you breathe in, and then you're gonna get carbon dioxide and water. Okay, and more importantly, from this process, you're gonna produce energy. Okay? And this energy powers everything that's happening in the body. Okay, breathing, the beating of the heart. Okay, moving the muscles. All those things requires energy. Okay, so where do you get carbohydrates? Well, there's certainly no shortage of carbohydrates in Western diet. Starch is a main source of carbohydrates for many people. Right? When you eat rice, corn, wheat, potato, pasta, cassava, yam, all those things are very starchy, right? And the starch is carbohydrates. Okay, it's good, it's filling, it makes us feel full, and we can use energy from them. There are carbohydrates in the form of fructose. Okay, fructose are found in fruits. You think of banana as really sweet. The sweetness is caused by fructose. Okay, you can also get it from artificial processed source like corn syrup. Okay? Sometimes a lot of the processed food they have what's called high fructose corn syrup, and that is very unhealthy for the body. Lactose is another kind of sugar. You probably have heard of it. You can get lactose from dairy products, right? Such as milk, ice cream, yogurt. What else? Sour cream, yeah. And cream cheese or cheese, right? Okay, so all those things are rich in lactose. What do we call people who cannot have lactose? That's right, lactose intolerance. Sucrose is another one. That is kitchen sugar, right? The sugar you use in your kitchen is sucrose. They are also the main kind of sugar that is in candy bars. Okay. All right, so let's try to connect this with our overall theme. Remember, I told you the macromolecules are polymers, right? Long chains of repeating units. So we have to know what the building blocks are. The building blocks, the monomers for carbohydrates there are three of them that I want you to know. So remember for the quiz. Number one, glucose, right? Which is the one we prefer to burn, right? As fuel. What does glucose look like? If you draw the chemical structure of glucose, and you will learn how to draw chemical structures in chemistry class, but if you draw it out, it will look like this, and it's a hexagon. Okay, you see all these OHs, right? So that's basically what we saw earlier, right? You know, this hexagon thing with the OH, that's basically a glucose molecule, right? But I took away all the complicated stuff to make it easier for you to understand. So over here, glucose is a monomer. Fructose is a monomer, and it looks like a pentagon. And we have something else called galactose. These are all individual building blocks for making the polymers. You are not responsible for drawing these things on the test or quiz ever. And I will never show you a picture of glucose, fructose, galactose and ask you what it is. Okay? So you can rest easy. But you should know, you should remember, these are the monomers. These are the building blocks. So they, on their own, are single sugar. And we have a special name for them. Right? Mono means single, and saccharide, monosaccharide. This means single sugar. Monosaccharide. Right? So glucose, fructose, galactose. So they are single and they are ready to mingle. When you put two of them together, they will partner up and they will form a double sugar. Double sugar. So double is di. Okay, so now they are disaccharide. Okay? Monosaccharide plus monosaccharide, when you connect them, disaccharide. Disaccharide. Okay? How do you connect them? Well, it's what I've been trying to tell you. You take a hydrogen OH from one and you take a H from the other and you remove it. What do you get out of it? When you take the OH and the H and you take it out, what comes of it? H2O, right? You see? Okay. And then you're able to form a bond, right? Okay. This is called dehydration synthesis. You already wrote it down. So when you take glucose and you connect it with a fructose, the result is sucrose. Right? Sucrose, in case you forgot, this is your kitchen sugar. Right?
Wait, so that arrow, that.
Yeah, it becomes, that's right. So when you consume sugar, when you have candy or have a spoon of sugar straight from the kitchen container, the sucrose goes into your body and your body will break it down back into glucose and fructose by adding water, right? Hydrolysis, remember? And once you break it back down into glucose and fructose, you will be able to burn the glucose in this reaction, and then it gives you energy. Right? That's why sometimes you're falling asleep in class and you have some candy in the mouth, like you might feel a sudden surge of energy, right? For a little bit. Yeah, that's the glucose, right? That you're burning, and it gives you the energy. Okay. Let's take a look at the various combinations you can get by combining the different monomers. You can take glucose plus another glucose, and you will get maltose. If you look at the ingredients of a candy bar, you will almost always get maltose. It's kind of like this very thick, viscous, almost like toffee and caramel kind of texture. Okay, maltose. Glucose plus galactose, that's going to give you lactose. It's easy to remember because the name has lactose in it, and then you're going to get lactose. And then finally, glucose plus fructose gives you kitchen sugar, which is sucrose. So just to reiterate, these things here, these are monosaccharide. Try your very best to spell them. But if you miss a letter here or there, as long as I understand, it's okay. And then over here, these ones, what do we call them? Disaccharide. Okay. So a couple ways I can ask you this on the quiz. I can straight up ask you glucose plus galactose. What does it give you? And you have to know it's lactose. Okay. I can mix these up in a list, and I ask you which of the following is a disaccharide. Okay. The bottom line, just remember that. Any questions?
Can you say one more time about the disaccharide?
Sure. Do you understand the monosaccharide? Yeah. Okay. Monosaccharide is like just one single sugar. Okay. Give me a second. All right. So let's say this black one here, that's glucose. Okay. That's monosaccharide. This one here is fructose. That's also monosaccharide. I can put them together, and now I have two stuck together, right? This thing, because it has two sugar in it, it's a disaccharide. Okay, disaccharide, double sugar. Okay, and depending on the components, they have different names. Okay? If it's glucose with another glucose, then it's maltose. Okay? If it's glucose with galactose, then it's lactose. Understand? Anyone else? Okay, hang in there. We're almost done. So lactose intolerant is people who don't have, it's called enzyme. Okay, we'll learn about that next class. But they don't have the enzyme to break down the lactose. And so the bacteria in their system will break them down for you. And in the process, it creates a lot of gas and bloating and makes you feel unwell. But if you're lactose intolerant, you can buy the missing enzyme, right? You just have to pop one of these pills before you enjoy your Sundays, and it's going to be okay.
Being lactose intolerant, inherited.
Good
like,
question.
it-
Yeah. So there are two kinds of lactose intolerant. People who are born lactose intolerant, you will know right away because the baby would be sick just from the mother's milk, right? So they have to be put on special milk that has low level of lactose. In other situations, because dairy product is not a main part of some cultures' diet. So yeah, dairy. Yeah. So once they grow up, for example, they no longer take dairy, and then the body takes that as a sign of, hey, I'm not receiving any dairy products. There's no need to make the thing that breaks down the lactose, and then your body stop making it. So if one day you decided to have a tub of ice cream, then all of a sudden you don't have the enzyme to do it, right? In those situations, you can slowly build your tolerance back up, and you'll be okay. Yeah. You, yeah. Go.
Because I'm lactose, like I'm only, it seems like I'm only lactose to certain things, but for other stuff that contain dairy, like nothing. Is that like a thing?
It could be, or it could be like I mean, like it depends on how much lactose is in the product as well, right? Sometimes maybe there's certain threshold beyond which is gonna make you ill, right? Or it might not be lactose, it might be other additives in the thing. Yeah.
So what happens when you consistently like been drinking milk like your whole entire life, and then all of a sudden you develop
Lactose intolerant is I'm not sure.
Like-
No, I don't know. It could be sometimes it could be just like an imbalance of the gut flora, and that's why people say take probiotics to kind of rebalance it. Maybe it has to do with that instead of the lactose. Yeah, like not everything is necessarily related to the lactose, right? Okay, so we went from monosaccharides to disaccharides, right? Di is two, right? But the example I drew for you is like many red circles together, right? It's like a long chain. So when we put multiple glucose together, keep on connecting them, then you end up having polysaccharide. Poly is long, right? Like a polymer, right? So I have three, actually four, but only three on the screen right now. Polysaccharides that I want you to know. Okay? They are all made up of glucose. Okay? So it's just a bunch of glucose connected together, but the way you connect them is a little bit different. Okay? I'll show you. So we have cellulose, glycogen, and starch. Okay? Those are the three kinds of polysaccharides. They are all made up of glucose. Let me show you. Starting with cellulose. Cellulose. So cellulose is the fibers in plants. Okay, specifically, they are found in the cell wall of the plants. Don't worry too much about that now. When we learn the structure of a cell, you will have a better understanding of what the cell wall is. But essentially, it protects cell. It protects the plant. It gives them structural integrity, right? It forms the fibers in the plant. We humans, we do not have cellulose in the body. Okay? When we eat plants, the fibers that we get from plants, we actually cannot digest them either. Right? But fibers are important because it moves our intestinal tract. It maintains like healthy dietary health. Okay. Right. So you guys ever seen a commercial where there's this product called Metamucin, and they have these people sliding down this. No,
Yeah.
I watch too much TV, right? But it's basically like fibers that you can drink, and then the people are sliding down the slide happily, as in like your bowel has really good movements, right? Yeah, so it encourages bowel movement, and that's what cellulose do for you. Okay, that's what dietary fiber does for you. You are not eating fibers for energy. You get zero energy from it. You're eating it for healthy bowel movement. Animals that graze, like cows, deers, do you know they have more than one stomach? Cows have 4 stomachs, okay? Because the grass that they eat has high cellulose content, and they actually have special bacteria in their stomach to help them break it down for energy. Okay, if you look at a cow, they always are chewing. Right? They chew and then they swallow, and then after a while, they actually have to vomit it back up and chew more. Okay, it just keeps on going back and forth in order to digest all these cellulose. Okay, fun fact: every time the cow regurgitates, every time it burps out a lot of methane gas, and that methane gas contributes to global warming.
I
Okay.
like that. I thought it was farm.
That too, okay? It comes out both ends, okay? And that's why they say farming cattle for the purpose of food is actually very bad for the environment. Right? It's because of these constant regurgitation and production of methane gas. Okay, so that's cellulose, okay? It's the fibers in the plants. Plants, they make their own food by staying in the sun, right? Photosynthesis. And when they make the sugar, they store it as starch. So starch is an other kind of polysaccharide, okay? They are a storage form of energy in plants. Where do they store the starch? In the roots, such as the potato, or in the stems, right? Of course, we eat them and we get energy from them. So you can see the starch has two kinds of structure. One is non-branch, and then the other is branch. Okay? Branch just means like this. Non-branch means it's like straight. A branch means, it branches. And then later on the next slide, you will see other polymers. They are even more extensively branched, okay? But regardless, they are all made up of glucose. You see these individual hexagon? Each one of them is a glucose. Okay, glucose, glucose, glucose. What about us? Where do we store our carbohydrates? If you eat more than you need, you will store the excess as glycogen. Glycogen, okay? Glycogen are stored in either muscle or your liver. Can you show me where your liver is? You know, which side is it?
That?
It's over here on the right side, okay? Yeah, underneath your diaphragm, okay? That's where your liver is. And you will store excess carbohydrates in the form of glycogen in the liver. Okay, so if you didn't have lunch and you're running on fuels right now, you're basically taking the sugar from the liver. Okay, so you will store the glycogen like that in the liver, and when you need the glucose, you basically just break off a glucose a little bit at a time. Okay, and to break it off, you add water, right? Remember hydrolysis. Okay. So that's the starch in the potato, glycogen in the muscle, and then the cellulose in the leaf, which we don't eat. Last one, chitin. Okay, this is pronounced chitin, C-H-I-T-I-N. Chitin is a special kind of polysaccharide, which is made up of modified glucose. It's like glucose, but it has like nitrogen in it, which makes it stronger. And the chitin is an essential part of the shell for things like crabs, lobsters. We call them crustaceans, right? Okay, so this exoskeleton, very strong, is made up of chitin. Okay, same thing with the exoskeleton of insects. Okay, like the bugs, they have the skeleton on the outside, right? Okay, that material is also made up of chitin. We do not have chitin. We do not have cellulose either. Okay, but we have figured out a way to use chitin. Right? Chitins are used to make surgical threads. Okay, they make it synthetically in the lab. They don't like extract it from the crabs or anything like that. They use it to make surgical threads, and because it is an organic molecule that originates from living things, it is biodegradable. So when they stitch you up after removing your wisdom teeth or something with the chitin, the stitches will automatically dissolve in your mouth. Okay, so you don't have to go back to remove the stitches. It will make the wound heal faster and heal better. Okay. All right, I'm just gonna quickly summarize everything for you, and then I'm gonna let you go. I know it's a lot, but here we go. Okay, monosaccharides, which are the monomers, okay? So we have glucose.
No.
Yeah, that's okay. Fructose and galactose. Okay, all the sugar ends with O's. OSE, OSE, OS. Now, to remember the disaccharide, just remember it's always going to be one glucose. Always. It's always glucose plus something. So you can have glucose plus glucose. It's maltose. Yeah. Remember, galactose is another easy one. Because you see the word lactose, then it's just going to be lactose. Okay. And the last one? And that gives sucrose, right? Polysaccharide. Sucrose. Shu and then rose, right? Sucrose, yeah.
So it is SH. So.
Okay, polysaccharide, we have a few. Starch, which is storage, form of energy for who? Plants. Glycogen, storage form for animals. Yeah. Almost there, hanging. What am I missing? Two more. Yep. Chitin. Exoskeleton, right? Now on the test or quiz, right? Please don't just write exoskeleton, right? Like you need to explain to me, right? Okay. Like exoskeleton for crabs and insects, right? Like elaborate a little bit. This is just a quick summary. And the last one. What am I missing? Cellulose. That's right. Which is structural support for plants. Okay. So I recommend this is how you study. Don't just read the notes. Okay. It's different when you write it out. It will help you consolidate your learning and remember it better. Okay. Thank you. I will see you guys next week. Yeah, I'll leave it out. Yeah.